What is up, everybody? Jordan from Poison Noises here, doing another big nerdy circuit deep dive on some of the most legendary guitar pedals in history. If you haven't caught up on the previous videos we did the Dallas Rangemaster, we did the Germanium Fuzz Face, we did the Proco Rat, and the last video we did was the TS-808 Tube Screamer. The way this works is I take a circuit, I try to draw it from memory, and then I go back and I check to see how close I actually got to the circuit. And then I bring it back here to you guys and I go over it part by part and talk about what each component in the circuit is actually doing. This is a big nerd deep dive. So if you're not into circuits, this ain't for you. I promise that right now. But what is the circuit we are doing today? Today we are doing the Electro Harmonix Big Muff. What was it? I think it was called a distortion originally. It's a fuzz. It is not a fuzz. It is the fuzz, above all else. There's been so many iterations of this pedal. Like I said, this is the triangle as far as I could remember it and as far as everything I could check. I got pretty much all of this right, and I was really happy about that. That being said, there was some stuff that I couldn't quite remember, like the names of the transistors. BC239s, they're just regular silicon NPN transistors. I usually use 2N5088s, not that that means anything to you guys, but little things like that. But the general shape of it I got, and most of the values I got right too. I was pretty happy because it's not a complicated circuit. It's only 4 gain stages, but it's more complicated than the other 4 I've already done. So let's jump into it. So first thing that happens in this circuit, at R2, you find a 39k resistor, so 39,000 ohms, which kind of gives it a little bit of input resistance, right, coming from the guitar or whatever it is that happens first in the signal chain, and you lose some high frequencies from it. This just kind of weakens the signal before it goes into the first gain stage. I don't really think this belongs here, controversial take, but not too controversial because most of the other Big Muffs after that did not have this component after. Next, we have C1, which is the 1 UF capacitor, 3.8 hertz high pass it creates right here, as well as, cleaning up some of the DC from the input. But yeah, I mean, what you're mostly doing here is you're rolling off more low frequencies, and that's in conjunction with some of the other components that are going on in here. This is actually, in my opinion, the most interesting part of the Big Muff. So you got another low pass here at like 1K to prevent oscillation in this feedback network. So if you look at it, like the base and the collector right here of this transistor has this 470K resistor kind of right here, and then it has in parallel this 470 PF at C10 capacitor. So it's feeding back, but it's really only feeding back low frequencies, so it's not getting super annoying and shrill, right? And that's pretty regular practice. That's not that weird. And then you kind of regulate the supply voltage. You reduce the voltage here with this 10K coming from our supply voltage, which in this case is 9 volts, and we're using ground as 0, so it is a negative ground circuit, right? We're using NPN transistors. We talked about that in some of the other videos. We're adjusting the signal strength going into it also with this 47K going directly to ground from the signal path, which is kind of adjusting our impedance. Like I said, our signal strength going into the transistor here. And then we're biasing it with this 100 ohm resistor between the emitter and ground. Now, what's really interesting about this is a buffer, by the way, for all intents and purposes. It's a buffer. That's pretty much all this is. We are creating a stable signal strength going into the gain stages, right? And what's interesting about this is that this is like a pretty low biased input for the transistor, which, like, teach their own however you want to do it. But what's really interesting is that as the emitter right here, as this current increases, it automatically adjusts itself. It's actually like a really good design for a buffer. It'll pretty much, regardless of temperature or variation in transistors or anything like that, it's kind of always working the way that the engineer, the way that Bob Meyer designed it to work. So whatever guitar you put into it, they kind of all are affected the same way, or a bass or whatever instrument, not whatever instrument, but for the majority of the stuff you could plug into it, they all kind of end up having the same signal strength coming out. It's a really good design. Even though it rolls off a lot of, interesting artifact and frequencies within the pedal. But that being said, at the output, you get another 1 UF capacitor, which cleans up DC at the input of that buffer, or rather the output of that buffer. And that goes into, we've seen this before. This is the shape of a guitar volume pot, right? The only difference is instead of pin 1, where the little dot is right here going directly to ground, we have some resistance between it, so 1K, so it'll never fully hit 0 volume. But our signal is going into 3 and coming out of 2. That is exactly how it works in a guitar volume pot. This is my least favorite gain knob design of all time. You are effectively putting a volume pot between gain stages, and usually it's between 1 and 2, which is what's happening right here. I just don't like it. It never sounds good at low gain. At high gain, it might as well not be there, which is great, because that's how you should run a Big Muff. You should run it with gain all the way up. If you don't, I don't know what's wrong with you. But it's just not a super versatile design. You don't get a lot of good sounds in different positions. Pretty much only one good sound, and it's all the way up. So next, we go to another cap around 100 NF. That's like kind of the cutoff point where like you're not really rolling off any low frequencies that your guitar didn't have already. Subjectively, I think it's closer to like 220 NF personally, but 100 NF is kind of like the standard for like if you just need to put a cap to clean up some DC and not really roll anything off. That's a great place to start, right? And then we have 10K, just like a current limiting resistor, again, just protecting from overcurrent, going into our next gain stage, right? So we got cascading gain stages. That's what we got going on here. We love cascading gain stages. The more of them there are, the fuzzier and crunchier things normally get. So adjusting the signal strength, the impedance here, again, putting 100K from the signal directly to ground, right? This 150 here is biasing this transistor right here. Okay, so this is our second gain stage, same kind of transistor, right? We have another 470K and 470 PF here. We already know what that does, right? It's a lot of repeating in the Big Muff. This creates that feedback, negative feedback loop, right? And then this keeps it from oscillating the high frequencies too much. And then this little section right here, we got a capacitor that kind of goes in series with these clipping diodes before it connects here. Now that's pretty interesting, because that looks just like the soft clipping we saw in the Tube Screamer. I know I said before I thought the Tube Screamer was the first soft clipper. I think it's just the first time I've ever seen it in an op amp. I mean, you see it in the feedback network of a transistor, obviously as early as 1970. That's when the circuit came out. So it's not that weird. It is the same diodes that are in a Proco Rat. Okay, these are like the most common diodes in the world. They're pretty interchangeable with the 1N4, 148s. If you see that, they're the same thing. Regular silicon diode with a pretty neutral, I don't know, I guess the average forward voltage drop. What does that even mean? The most common, I guess? I don't know. I'm just saying things now. And then we reduce our supply voltage here with another 10K before our supply voltage, which is 9 volts in this case, like we said. So that's just a gain stage with some clipping. That's ultimately what that is, right? It's really similar to what's going on right here. In fact, it's almost exactly the same thing, minus the clipping diodes and that one capacitor that we had there, right? It's almost biased the same too. Like, it's for all intents and purposes the same shape, right? And then you think that's bad. Check out the next stage right here. This is literally the exact same thing as this. Okay, so we are clipping and cascading twice. This is why the Big Muff had so much sustain for its time, right? It just pushes and clips and pushes and clips, and then it makes up for gain again. It's crazy. For its time, it's just like, I think the original idea was they just wanted an infinite sustainer. This is why. It's just because you have so many gain stages going. I mean, I say so many. There's pedals with way more gain stages than 4 than we're talking about right now. But it's literally just the same thing. It's like you just did, well, that's a lot of gain. Do it again. Like that's pretty much what, hey, if it ain't broke, don't fix it. Maybe do it again. Then what are we going into from there? Well, we are going into this really interesting tone circuit here. So here we have a low pass filter. Okay. So, in tandem with C8 and R8, okay, you get a low pass that kind of starts, well, it depends on how you adjust it, right? But it has kind of an endpoint at like 1K when it's in the middle at noon. And coincidentally, so does this high pass filter that's right here on this side. So this is entirely passive. There's no power going to this EQ section whatsoever. It's really just it's really smart. It's intuitive and it makes sense. When you turn it to the left, you're not getting more bass. You're actually just cutting highs. And when you turn it to the right, you're not getting more highs. You're just cutting bass. Some negatives to this. I mean, it's a really good design, but some negatives to this. It's like I talked about that meeting point at 1K in the middle, right? So you got two, you'll try to do it here. It's like, imagine you have a high, this is your low pass filter, right? Everything above here is cut off. This is your high pass, and it kind of gets pulled in either direction that way, depending on how you turn the knob. Well, right here, when it's in the middle around that 1K point, now we've got scooped mids. Okay. So you do lose some frequencies at 1K, but if you love scoop mids, like I love scoop mids, it's a good thing. You don't mind it too much. But even so, regardless, when you have high pass and low pass filtering, you are losing volume, which you wouldn't think was that big of a deal after all this gain staging right here. But even the clipping takes away some volume for us, right? So we have to make this up. And what do we do to make that up? Well, we need another gain stage. How about a fourth one, ladies and gentlemen? So next we go into 100 NF, which again cleans up some of the DC coming out of the output of the tone stack that we have there. We then create a bias point here with a little voltage divider, right? So we have 100K going to ground, 430K going to our voltage reference point. That means it's actually going to be lower than 4.5 volts going in. I don't know the exact number. I don't know. I really have to think about it. But if we go into this gain stage here, we have another buffer. This actually is a little bit more than a buffer. This actually kind of gives us a little bit of a gain increase because we bias it with this 3.3K here, which is a much higher value than we had at the emitters of any of the other stages, right? But we are giving it slightly less voltage than we did before. We're giving it we're cutting it back with current limiting resistor of 15K instead of 10K. But overall, adding this additional little capacitor to filter the DC coming out of that gain stage, you're recovering a volume loss of like somewhere between like 10 and 15 decibels, which is pretty substantial after losing it here. You know what I mean? Altogether, there's a lot of volume on tap still. I know people don't usually do the push thing with the Big Muff. They kind of rely on the crunch inside of the pedal is what they like and what they use. But yeah, after that, you just have your regular guitar volume pot like we talked about over here, except it's actually being used at the end of the circuit like a volume pot is normally used. This is another one of those brilliant designs like Proco had where all the values are the same on all the pots, but that's it. That's the Big Muff. The Big Muff is a whole lot of do it again. Thank you, sir. May I have another? There's some mods you can do this. I mean, you can change these diodes out. You can always change the diodes out. You want more headroom? Put LEDs in those spots. If you want less headroom, put germanium in it or bats or something like that. You can put higher gain transistors in. That's going to make a pretty big difference here. Any NPN, like I said, I use 2N5088s. Those seem to give me a pretty good sound. Adjusting the emitters and the supply voltage resistors, you could make pretty much any version of a Big Muff you want just by doing that. There's some tone stack changes too. I would maybe take out R2. I think I don't like that resistor. I don't like it. Get rid of it. First mistake that Bob Meyer ever made, putting that one in there. He adjusted though. He changes it in the future revisions and stuff. Maybe make this A100K instead of B100K. It's probably a better taper for volume. But that's it. There isn't much I would do to the Big Muff that hasn't been done to the Big Muff already. Some people like to cut these diodes out entirely. That's screaming loud. That's like the Supa tone bender. I can't remember what, some weird version of it or something. But anyways, guys, that is it for the Big Muff. I love the Big Muff. Hope you love the Big Muff too. If you guys like what I'm doing, please tell me in the comments. Please like and subscribe and do all that fun stuff. Follow if you want to see more of these. Tell me if I've made any mistakes, because I'm sure I have with how fast I'm going through here. Actually, I don't know. I've been pretty meticulous. So if you catch something, let me know and tell me what a jerk I am. But then also let me know what circuits you guys want to see. I would love to do more of these. I really would. I would absolutely love to do more of these. I don't really have any others on the docket right now. I'm sure there's going to be some that people request that I don't want to do, but I'm not even going to say them because I'm not going to give you the idea. So until next time, please do all the YouTubey stuff like I said before, and I'll see you around.